Good afternoon and welcome to today's Winter Science Speak seminar. My name is Jeff Schlotto, Director of the UC Davis Tahoe Environmental Research Center. To learn more about Turk, the research we conduct here and around the world, the public education and citizen science programs we provide for the community, and our work with agencies in the Tahoe Basin and beyond, please visit our website, tahoe.ucdavis.edu. You can also find out how to follow us on social media, how you can participate in our activities and help support them, including these monthly lectures. One of the goals of our seminars is to facilitate dialogue and discussion. We'll be addressing questions at the conclusion of today's presentation via the Q&A function on Zoom. Let me repeat, Q&A, not chat. So the only way to have your questions and comments addressed is to type them into the Q&A, and our presenter will try to get to as many as possible. Before I introduce today's speaker, I just wanted to give you a quick alert about a couple of upcoming events. Our next seminar will be on January 20th, again at noon. It will be by Dr. Randy Dolgren on wildfire impacts on soils. This is not the soils in New Garden, but on the soils of burnt areas in the basin. And then just so that everybody can get into training, in spring of 2022, we have Turk 2, our second circumnavigation of Lake Tahoe by kayak. Details will be forthcoming, but it's not too soon to start getting in shape for that. Okay, so a question that I'm sure you all have, I certainly do, is are we experiencing the early stages of a sustained dry period in the West, or are we on the precipice of a deluge this weekend? The first question relates to our climate, the second to our weather. Today, we're very fortunate to be joined by the person who can address both weather and climate. Chris Smolcom is from the National Weather Service Forecast Office in Reno. He works with emergency management, public safety, and partners in Eastern California, the Sierra, and Western Nevada to help them make good weather-based decisions. He's been with the National Weather Service for 21 years and holds degrees in atmospheric and oceanic sciences from the University of Wisconsin at Madison. Chris, a big virtual welcome, and I turn Zoom over to you.
Oh, super. Thank you so much for that kind introduction. And thank you again for the invitation to talk today. I've been doing kind of pre-winter presentations since about late September, and honestly through much of November. I was talking to various folks, and I'm like, I don't really have much to tell you because November was so quiet. But the timing of this is so fortuitous. I have lots to tell you coming up here. So I'll go ahead and start sharing my screen here. Before I do that, sometimes we have a little rivalry between Reno and Las Vegas. You know, sometimes we like to throw a little shade their way when they're like 120 degrees or whatever. And they sometimes like to throw some shade our way, you know, something like this. Las Vegas locally is kind of a fun Twitter thing to follow. But cold, dark, windy, rainy, and miserable down there today, apparently. We're basically Reno with good casinos. I don't know about that. But anyway, fun little rivalry there between the North and the South. So let's go ahead and get started on the presentation. And basically, you know, again, if you talked to me a month or two ago, it was like drought and fire and smoke and heat with just everything going on this last summer and even into the early autumn months. And so it just seemed like, was winter ever going to show up? And, you know, we had that big storm in October and like, oh, okay, here we go. You know, this is a boom way to really kick off winter. And then November happened, not a whole lot, kind of started getting us freaking out again about, ooh, is the drought back? Was that just the one storm we're going to get all winter? And so, you know, people are justifiably concerned about that, especially the ski areas. It's like, well, where's the snow? Where's the cold temperatures? We didn't even have cold temperatures that are good for snowmaking in November. It was very mild. But now we've got some stuff on the horizon there. So let's take a look at that. So I do a lot of running. Most of you that know me know that. I love getting up on the Tahoe Rim Trail, especially on the north and east sides. To say the Brockway to Mount Rose segment is probably my all-time favorite. So I do run commutes periodically between my house in Sparks and over to the weather office. And, I'm used to finding trash along the dirt roads there, burnt out, shot up trucks and stuff like that. But lately I've been finding boats, which is just a totally random thing to be running along. And then you look up on a hillside and there's an abandoned boat. Like, man, it takes a lot of effort to get something up there to do that. But, maybe, is this a premonition? Does this mean something? Is this important? Does this imply that it's going to be a very wet winter? So these boats are just magically appearing up on the mountains because we're going to need them sometime because there's going to be so much water. We're going to need these arcs to get around. Or is it the other way? Are people abandoning their boats because they just have this sixth sense that drought's going to continue and all the water's going to dry up? So why do I need a boat? So there you go. Those are two obviously extreme scenarios, but let's get into some actual science that talks about what we might expect. So this last summer, it certainly was extremely hot. Among other stats, in Reno, we did set a new record for the number of 100-degree days at 22. I think our average is on the order of 10 or so. I mean, the long-term average. So this is really anomalous, although we've had a number of these 100-degree days, these really high numbers in the recent years. You see that on the chart at the bottom. Closer to home in Tahoe City, this is a long period of record station that we had, goes back to 1910. What you're seeing here is the average temperature for the summer months, so June, July, and August. So you average all the highs and lows together, come up with one number. And over here on the far right, 2021 is the new standard bearer for a hottest summer on record in Tahoe City, and by a couple of degrees Fahrenheit too over the previous record. That's a big jump there. So Reno, Tahoe, and the entire West, look at that. That dark red is indicating those areas saw the record warmest summer on record, dating back to the late 1800s, all the way from both the borders, Canadian to Mexican border, across a good chunk of the West. Any of you who have friends in the Pacific Northwest know all about heat waves, what they saw there, historic heat waves in late June and early July. And actually, I will come back to that at the very end of my presentation today. So it seems like we have a fifth season now, smoke season. Everything was all hunky-dory this summer. It was hot, but until about mid-July, everything was normal, hot. But then we had all the fires take off, starting with the Tamarack fire. Then, of course, we had the Dixie and Caldor fires closer to home. This is a picture in early to mid-August when the Caldor was just starting to take off. Here's the Dixie fire, just tons of smoke in the atmosphere across the region. And, it's been 2 years now in a row that we've had these prolonged smoke episodes in our region. And as a logical scientist, 2 years does not make a trend. But, it's sort of like the writing's on the wall. Is this the new normal with drought and stress of vegetation, things like that, more of these large fires? Is this a new normal? And so kind of the emotional, the non-logical side of my brain is like, this is insane. I can't deal with this. And to that point, we were actually driving back from a race in the Tushers Mountains in Utah, which, by the way, if you ever have a chance to see the Tushers, just such a cool, rugged mountain range to run on. We were coming back through Ely, and we came into the smoke front. We came around a corner of a mountain range, and all of a sudden the visibility was like a quarter mile. I'm like, what is the fire like right there in front of me and I just don't see it? But no, it was hundreds of miles away. The smoke was just so thick. It was still even coming into the car with a recirculate on. And the emotional brain in me was like, to heck with this. I'm turning the car around and we're just going to start a new life someplace else, out of the house, the jobs, the school, all the logic brain stuff is like, we're done with that. And but we press forward and here we are, we get through it. But so here in Reno, we've had PM 2.5 monitoring consistently back to 1999, and we've set records for the smoke density. This year has the top three. Look at that, August 23rd, a 291 AQI, which 301 is hazardous. Remember, these are 24-hour averages. So it was even higher at various points on that day. And also notice the top 10 are now just in the last 2 years. Here's South Lake Tahoe. This is just a screen capture I did for one of our briefings during the height of the Caldor fire on September 2nd. And the preceding 7 days, there was only 4 hours of good air quality at the South Lake Tahoe measurement site. Look at all that hazardous air. I mean, just how do you cope with that? How do you, even if you're not directly affected by the fire flames itself, where do you get fresh air? I mean, you just have to leave, and unfortunately, you have to go hundreds of miles to get anything that's considered fresh. So, on a physical side, and then I'll talk about some of the mental health issues. But the smoke does affect the weather. It cools the high temperatures. It basically blocks some of that sunlight from getting through to the surface. So we actually will see temperatures 5, 6, 7 degrees cooler than we otherwise would have if the smoke weren't there. On the same token, on the overnight lows, though, those stay the same. Those are not affected by the smoke. The wavelength of the energy that comes off the surface of the Earth, more of a long wave radiation, whereas the energy coming in from the sun is more shortwave radiation. That does escape back into space quite readily, as if the smoke weren't there. So your overnight lows actually stay the same, meaning you have a smaller spread between your high and low temperatures when you have these smoky conditions. And sort of related to that point, this helps mute the zephyr wind that we often see, not as much in the Tahoe Basin, although it does happen periodically, but more so like Truckee into Reno. We see that really gusty westerly wind in the afternoons every summer day. And the smoke essentially kind of muted that because it limited the temperature differences between the mountains and the deserts of Nevada. So it acted to kind of keep the smoke entrenched in the area more than obviously we would like. But on a silver lining note, is what it did do is we had a couple days where we put out red flag warnings for fire weather concerns because the winds were supposed to be really breezy. Well, this actually kept the winds just low enough where it didn't meet those critical criteria. So in a way, it helped potentially if there were new fire starts that they wouldn't get out of control as quickly because the smoke was there. So kind of a feedback mechanism, if you will. So why are we having so many of these huge fires? And this is sort of my take on it. Others have similar takes, maybe some different takes, but look at that one picture there. I was running the Tahoe Rim Trail endurance races with my wife in mid-July. Her first ultra, which she completed. It was a super awesome day. And this is on Snow Valley Peak on the north side. Look at all that dead vegetation there. There's some really big clusters of dead trees on the east side of the Tahoe Basin. Another one is up at the top end of Thomas Creek. If you do the Rim to Reno Trail, there's a lot of this stuff. It's like, man, this really freaks you out. There's a lot of this, so that provides a prime fuel for really large and intense fires. And so to that point, we are now having these things what are called plume dominated fires. These are just a couple examples from the Tamarack and the Beckworth, the Dixie, the Caldor, the Creek Fire last year all showed the same behavior where they essentially look like bombs went off. And there's very similar characteristics to what developed thunderstorms as to what developed these kind of large, massive fires. Of course, multi-year drought, record dry timber vegetation is numero uno on making these fires so large. And going into this summer, we knew it was going to be a big fire season in the Sierra, barring an active monsoon with a lot of rain, which we didn't really have, because the timber fuel moistures were so low even in May. So we knew ahead of time that it was going to be that way. And that's why we're really hoping for a big winter, because that will help the fuel moistures in the mountains not be as low. So that was number one. Number two, longer and more intense heat waves, which of course we had. You saw the stats on that, the number of 100-degree days. That dries things out even further. And then lastly is a dry and unstable atmosphere. It's the same configuration of the atmosphere that is conducive for thunderstorm development, also helps create these large, what we call pyrocumulonimbus clouds that efficiently take the heat from the fire away into the rest of the atmosphere. And so it's kind of like a cycle, just keeps that heat going and then takes it away. And then there's more heat and it just keeps cycling around to create these large, massive fires in this dry, unstable atmosphere. If you've heard of the Haynes Index, that's a parameter that we use to predict that dry and unstable atmosphere. So you put all these three together and you have what are called these plume-dominated fires. And the unfortunate aspect among many on these is once they become plume-dominated, they do not care what the rest of the weather is doing around them. These fires will keep going. They create their own weather. They get so big. And at that point, the fire agencies sort of just have to say, we're going to do the best we can, but these fires are going to drive themselves until there is a really big change in the atmosphere. So either an early season rain or snow event or a day with a lot of thunderstorms with rainfall. Those are two ways to kind of get rid of these big fires, but you really just have to wait until those happen. So that's one of the reasons why the fires got so big in terms of acreage this year, the Caldor and the Dixie as an example, is we really didn't have any of those fundamental change events until very late in those fires. So that's what's going on there. So now, kind of the mental health aspect, and I think this is an important thing. You know, obviously there is the physical toll, the property destruction, the lives lost due to these large catastrophic fires. Absolutely. But for the millions of people around them that are affected by the days, weeks, and honestly, even months of dense smoke, that does take a mental health impact. And I'll just speak for myself that I am one who, I live here because I like the outdoors. My mental health valve, my coping mechanism with life is running, is getting outside. And when I can't do that for long periods of time, or I do it and it's a questionable decision at best, or I have to shorten it, you don't want to be around me. And so if you've had those similar feelings, you know, we all live up at Tahoe for the same reason. We love being outside. You're not alone. If you've had those feelings, you are not alone. And so I think that's something just to keep in mind during these prolonged disasters like that is the mental health toll over a much wider area. It's not just the area directly affected by these big fires. It's over a much larger area. So you see there on the picture on the right-hand side, I did an experiment with one of these surgical masks that in theory does filter out the PM 2.5. And I think it actually worked. I only did about an hour of running, about 6 miles. But when I got home, my breathing felt fine. I didn't have any issues there. I wasn't hacking up a lung or anything like that. But my clothes, oh my. I mean, the smell is like, was I like sitting by a campfire the last hour? It was just really, really amazing. So, all right, let's fast forward to some more positive news. Let's get out of the summer smoke and heat and all that. Let's talk about that Superduper mega atmospheric river that we had back in late October. Here's a picture from a park in Sparks. It actually is kind of a flood basin, so it's supposed to do this, but obviously the porta potty there is not having a good day. This was largely a beneficial atmospheric river to the region. You know, we did have some flooding issues, but fortunately it came down at a persistent light to moderate rate for 36, 48 hours, that the burn area saw some impacts, but they didn't have really significant debris flow impacts. And I'll touch on that later in the presentation. So it was largely a beneficial event for us. And I'll talk on that in a couple of slides. Here's a picture from the Carson Valley near Genoa the day after the storm had left the area, a very picturesque scene. So it definitely replenished the soil moisture in the area. And to a point, though, where if we were to have additional heavy rain events, especially in the lower elevations, let's say down toward Reno, Carson, that flooding could be a concern, more so than it was going into this event. Had we had this atmospheric river in January, after even an average lead up to that, flooding would have been a very significant concern. So here's a satellite image of this storm. You could write a textbook of meteorology just from this satellite loop alone. But we're going to focus on this giant storm off the Pacific Northwest. This is what's called a bomb cyclone, which I'm sure you heard the term during this storm series. It basically just means a storm that is intensifying rapidly. And to that point, you see all these little color light ups here. That's lightning strikes that the satellite's actually detecting. That's a new feature on our GOES satellite. It can detect lightning anywhere around the planet in real time. So that's super cool. But for us specifically, it's this stream of clouds that is coming off the Pacific Ocean all the way back to Hawaii. And this is the atmospheric river. These are streams of moisture that come out of the tropics into the mid-latitudes. And they're super important, super beneficial for us for our snowpack, our water supply, a healthy ecosystem in the region. We get about 5 to 10 of these on average each year, and they can amount to over 50%, sometimes 60%, just a handful of storms of our annual snowpack and water supply. So very important for the region. Now, if we have too many of them or they're too strong, then that's where we start getting the hazardous weather, the flooding, the blizzards, the damaging wind events. So again, this one was largely beneficial for us because the lead up to it was so dry. So we really needed the moisture, even if it was super, super heavy and unusual, but we really needed it. Now, also for this storm, it was very unusual for so early in the storm season. This event would have been strong in January or February, but because it occurred in October, it was really notable, very unusual, again, for this time of year to have that. So I kind of called it hitting the environmental reset button after that super hot, dry summer. Lake Tahoe rose a half a foot, that's a lot of water. And it's only the 8th time in 121 years of record that Tahoe has seen a net rise in October. So again, very rare for so early in the season. Now, at Tahoe City, at our co-op site there, again, records dating back to the early 1900s, we saw about 7.5 inches of precipitation. Now, that's mainly rain, but there was some snow at the end of the storm, so it melted down to liquid equivalent there, 7.5 inches. It's the 9th highest 2-day total on record. Again, dating back to about 1910. So 9th highest amount of precipitation in a 2-day period any time of year. So that's pretty remarkable. Number 1, though, for October and November, dating back to 1910. Again, another stat to show you how unusual it was for so early in the storm season. That one storm was nearly half of the total for the entire water year that we have leading up to it, which that water year was also the 4th driest on record. So in Reno, they actually were much closer together. It was about 3 inches of precipitation from the storm and about 3 inches for that water year leading up to it. So it's almost 1-to-1, which tells you another aspect to the storm was the really efficient spillover. There was no rain shadow whatsoever with this storm. So everything just came right on over. And so that's why Reno's is so notable. It's actually 40% of the annual total that we got here. So does this help the drought? Yes, it does in one specific aspect. It really increased the soil moisture in the Eastern Sierra, ranging from the Truckee River all the way down to Mammoth. You can see this black line is the soil moisture from the Snowtell sites, and it went from near record dry to basically record moist levels in the Eastern Sierra, and we're still really high. So again, if we were to have a very warm atmospheric river, a pineapple express, if you will, flooding would be very high on our threat matrix, so to speak, on our freakout chart that we put out. That would be a concern. But on a very, very positive note, what this did is, let's say we get our big snowpack this winter. Let's say it's big, but it's not too big. We don't want too big, like flooding big. And then we melt it off in the spring. So what this will do is the soil underneath that snow is now going to be moist. So the snowpack, when it melts, instead of going into a dry sponge soil situation like it would have done the last couple of years, it actually just run right off into the creeks, the rivers, the lakes, the reservoirs. Going to be really good for the water supply. It's what we call efficient runoff into the ecosystem. So that's really good. We needed this storm bad to really help set that up for next spring and next summer. So thumbs up on that from this one event. All right, let's fast forward a month. So up until recently, this is my daughter Savannah and my son Carson. Savannah's, of course, leading Carson in the dust on the trails down by Thomas Creek. So I kind of was like, oh, well, this would be here's Drought. It's taken the lead. Our actual winter's like way back there. Carson, come on, keep up. But hey, remember, we still got months to go, and we got some stuff on the way, and so maybe Carson's going to make a run for it here. So yeah, as of right now, snapshot, the snowpack is definitely below normal. It's that top graph there. You're seeing the black line is well below this green line, which is the average snow water equivalent content for the Eastern Sierra. We're at about 37% of the median for this date, but we're still really early in the storm season. So lots of room to go there. The bottom graph is showing you the accumulated precipitation, again, for the Eastern Sierra Snowtell sites. And we're way above normal on that one, because that's the rain plus snow that we got, a lot of that from the October event. So we're basically at levels that we typically don't get until about New Year. So we're ahead of the game on that. But in terms of the snowpack, we're definitely below average right now. So let's hope we can pick up on that here soon. So a wet October plus a dry November, does that pairing mean anything in terms of a predictive power? 2016, 2017 was that exact pair. Very wet October, very dry November, and then it was off to the races in storms for the rest of winter. So are we going to mimic that? Well, here I did a bubble diagram. It took me forever to figure out how to do a bubble diagram. My Excel knowledge is a bit dormant. So I did this, eventually was successful. But what you're seeing here is a bubble diagram comparing October precip with November precip, and then the size of the bubble is the rest of winter, so December through March precipitation. There's our friend 2017, big bubble there. And we would be right about here for this year. Of course, we don't know what the size of the bubble is for the rest of winter yet, but we're out here kind of in a rarefied territory. Haven't seen anything like that yet. But overall, there's just no predictive power in knowing that you had a wet October plus a dry November. It doesn't really tell you anything. There's also been dry examples, rest of winters, say that 3 times fast, including 1994 is the most recent one. There's 2011. That was the 2010, 2011 was a pretty wet, fairly snowy winter, very, very efficient snowpack winter there. So fortunately, we can't use that as a correlation. All right, so let's look into the actual models. We run hundreds of models every day. Let's actually see what some of that output says. But before we get started, I took this picture at Cost Plus World Market a few weeks ago. It's kind of random, but I had to take a picture. I'm like, the Bob Ross positive energy drink. Are you kidding me? I was like, wow, I'd never seen that one before. And then right above it, it's the Liquid Rage positive energy drink. And I took this actually just before that October atmospheric river. So I think on that one, clearly that was Liquid Rage variety. So for the next 2 weeks, are we in for some Bob Ross nice little storms, or are we in for more of that Liquid Rage kind, or maybe Solid Rage if we're looking at Snowpack? And I think it's going to be more the latter, especially as we get into early next week. So here are the forecasts. This is what I call a most likely scenario. It's kind of in the middle of the road of the various model simulations that we run. Some show lesser amounts. Some model simulations actually show higher amounts of precipitation and snowfall. So this is a big picture view from basically Tahoe down through the Eastern Sierra toward Mammoth and Bishop, since I actually did a presentation for folks in Mammoth this morning. And the left-hand graph is the precipitation, so that's rain plus any snow melted down. Of course, for the mountain areas, it's mainly snow or water equivalent in the form of snow. And then the snowfall from the model, the middle of the road, is here on the right-hand side. So the areas in yellow are 5 feet or higher of snowfall through next Thursday, the 16th. A lot of this is projected to come down Sunday afternoon, evening, Monday, Tuesday, and into Wednesday. And now there's some signs. Late breaking news of another system coming through on Thursday. It wouldn't be as big, but it would be colder. So it'd likely be more efficient at producing snowfall out of maybe even lesser precipitation amounts. In fact, that Thursday one could be decent down here. So, but of course, we're still a week out. We have to get through this first one first, but really healthy snow totals coming up. Multiple feet of snow in the Tahoe Basin are a pretty good bet at this rate. Now, that was just one forecast, and I like to show you the full breadth of possibilities from our various models. And this is a way that we're going in the Weather Service, is to provide more of a spectrum of information on what we're looking at here. So this is something we started factoring into our weather briefings, is looking at, if the storm was to just go off the rails and the atmospheric river petered out, or it moved through really too quickly, what's the minimum snow we would get? And that's what I kind of put down here is the underperform. So still, hey, a foot of snow at the Lake Tahoe elevation is nothing to sneeze at. 1.5 feet for the say top of Palisades, Olympic Valley, Donner Pass. The overperform and the oh my's are the simulations that are exceeding what we, some of the middle of the road scenarios. So many feet of snow, even in the Lake Tahoe communities, if kind of the stars align, the cold air stays in place, the atmospheric river moves through at a relatively slow rate, which is what we think will happen. It's one of the main reasons we think this will be a big series of storms, as the AR is kind of settling along the coast at a very slow rate of speed. So these higher end scenarios are certainly attainable at this rate. So look at that. I mean, over 5 feet of snow at the top of the mountain, 85 inches. I mean, wow. Honestly, even Slide Mountain, Mount Rose could see some of that kind of stuff. So the percent changes, just the chances for your reference, it's a probability of exceedance. So what I'm saying here is that it's 75% chance of exceeding a foot, 25% chance of exceeding 45 inches, and a 10% chance of exceeding 70 inches of snow. So that's how we put it here. It's maybe a little confusing at first, but essentially you're just looking at the spectrum of possibilities of snowfall here. Now, maybe I'm taking this concept too far. I was trying to think of a way to train folks on how to interpret this. So I'm like, well, how many times do I reheat my coffee in one day? because you know that coffee always tastes better the more times you stick it in the microwave and reheat it. Said nobody ever, really. Well, on this day, I only did it 4 times before it became unpalatable to keep drinking. So it did hit the forecast. So we're between the 2 and 7 is in between the underperform and the overperform. So I did a good forecast there. All right, looking out to week 2, this is getting into Christmas week. So we kind of have to take a step back, just look at the really big picture weather patterns, but it still looks favorable that we could see additional storms, and they would be of the cooler than normal variety, which would be good for additional snowfall. And so I kind of put this as the storm door isn't like wide open and we're just going to be letting through big monster storms. We don't know that yet, but at the very least, the storm door is unlocked, or maybe even a little bit ajar. There's some possibility for some additional activity. And if it did, it would probably be good for the snowfall. And this is a graph talking. Remember, I talked about how the atmospheric river was kind of sagging along the coast slowly as we go through the early next week. Well, this is a chart showing you the probability of atmospheric river conditions at various latitudes here in these black dots in the Sierra foothills. And right at our latitude, look at that. You've got almost 48 hours of AR conditions there, right into the central and northern Sierra. So this is why we think this should be a big event in terms of precipitation for the Sierra, especially from like Tahoe, Mammoth area, that zone. I still, I've been in this job long enough where I'm just like, okay, what's going to go wrong? What's it going to do when we get closer? But there's a lot of points that point towards something decent. And the other thing is this AR is coming at us from the southwest. That's what you're seeing here, these wind vectors coming out of the southwest, which is the prime orientation that we need to squeeze out as much moisture as possible from these AR events. Oftentimes, with a couple of exceptions, if the ARs are coming in from the northwest, they can't squeeze out as much moisture as efficiently in our region. So it's just a bunch of clouds passing overhead. And it's like, oh, stop, please give us some precip. But these southwesterly ARs, boom, that's what we want. So I think we got some goods on the way. This is looking out toward Christmas and New Year's, maybe a little bit beyond. There's a very slight lean toward above normal precip and below normal temperatures. It's a very soft lean. It's just again, it's hinting that storm door is. I would even go to the unlocked. Maybe not isn't open, but it's sort of unlocked. We could still have potential storms coming through that far out. So let's hope for some optimism there. So going into the rest of winter, we are in what's called a weak La Nina signal, and this is what everybody talks about: El Nino versus La Nina for the winter outlook. So we're in what's called a weak La Nina. But for our latitude, there really isn't a big dependence on El Nino versus La Nina. We've had very dry versions of both in the Sierra, and we've had very wet versions of both. This is almost a perfect scatter plot. You can't go wrong with an R squared of 0.01 to indicate almost a perfect scatter there. So this is just, again, something that El Nino and La Nina generally don't have a huge correlation on our winter weather here at our latitude. So to that point, the official winter outlook does have an equal chances. Really, any scenarios on the table for our latitude. You see the brown shading here, which is a leaning drier, but I really think at this point, anything is on the table for January, February, and honestly, even into March, including on temperature. That's interesting. That's a little bit of a difference there, that it's not showing warmer than normal. So there is some potential that we end up with a cooler than normal winter as well. And a way of looking at this, which shows the scenario are possible, is a pie chart. It shows you that there's basically equal chances of various scenarios occurring this winter. So don't rule anything out for the balance of winter. Right now, it does look like the balance of December should be pretty optimistic for us on storms. But going into January and February, really any scenario is on the table at this point. So how do these seasonal forecasts pan out? You use something called a Heidke skill score here. This is for the December, January, February precipitation forecast. The areas in red are where you do see improvement over a random roll of the dice. And so that's good. That's where the forecasters and the models are actually adding skill to those seasonal outlooks. But notice here, we're in the white zone. is for immediate loading and unloading of passengers only. There's no parking in the white zone. Remember that scene from Airplane? So here we are, basically similar skill to random roll of the dice, which again is the El Nino and La Nina just don't have a lot of bearing on us at this point. Looking out my window at Pivot, and I think I can see the snow melting as I'm talking here. So seasonal forecasts at this stage, they're too good to ignore, but they're not quite good enough to use. How do you like that for a statement? So we're at that stage. The seasonal forecasts are getting better with time. They are improving, but are they really good enough to use, especially here in the Sierra? I'm not quite sure yet. So random roll of the dice might be, the 8-ball might be a pretty good option there. So the weak La Ninas, one interesting aspect of these weak La Ninas, we have statistically seen some of our higher water winters during these weak La Ninas. We don't know the physical mechanism, and it's not a guarantee. We've seen plenty of average water, water flows during weak La Ninas, but we've seen a lot of our high water years. So I show this because when I talk to emergency managers, I tell them, based on the statistics alone, this might be a winter to maybe dust off your flood plans, maybe give it a little extra TLC going into the winter season. And that's what I'd say to you as well. If you have any flood concerns or live in a flood prone area, just make a little extra TLC, double check a couple things, things like that. Make sure your ditches are clear, your gutters are clear, things like, just things like that. So I want to go into the post-fire flooding issues. And I know the next presentation is going to be talking about fire effects on the soils. And actually, as Jeff was talking about that, I actually put that on my calendar for next month. It looks like a great presentation. So I'm just going to talk about the weather aspect of these post-fire concerns is, when you have such intense fires, it essentially cooks the soil to become hydrophobic and the water just runs right off. It floods a lot more readily, and you create what are called debris flows, where boulders and debris and trees and things like that just come right on down the mountainside. And they occur with little or no warning and with relatively little amounts of precipitation. Even just a quarter inch in 15 minutes is enough to trigger some of these major debris flows. Now, fortunately for us here in the Sierra, this is usually a summertime problem. So we've probably got some time before we really experience these. Because we have to wait for those really intense summer thunderstorms. But we can't entirely rule them out in the winter either during some of these atmospheric rivers that can produce what are called narrow cold frontal rain bands. And I'll have an example of that. It's basically a squall line of higher intensity rainfall. Now, the Weather Service, we are part of an interagency analysis team that goes in after these fires to help assess the risk for flooding. Our amazing hydrologist, Tim Bardsley, here at the NWS Reno is part of those teams. And he goes out with the BLM, the Forest Service, and others to help assess the risk for flooding. So the two scenarios that we're really worried about when it comes to these post-fire floods are, number one, thunderstorms. This is an example from east of Grand Junction near Glenwood Springs this last summer on I-70, where just about a half an inch of rain in short order caused a debris flow on a recent fire and closed out Interstate 70 with multiple feet of mud and rocks. And any of you who've driven I-70 through Colorado know there's nowhere else to go. I mean, once you're on that interstate, you're on these bridges and there's really no place to go. So a lot of those vehicles were sitting there for quite some time until they could get that cleared off. The other one is that narrow cold front of rain band. These are wintertime squall lines that more often affect coastal California and maybe the west slopes of the Sierra. Not so much the Tahoe Basin and Reno. Can't rule it out, but usually it's more west of us. But these provide high intensity rainfall situations. And a very unfortunate example of that is the Montecito debris flow that occurred in the middle of the night back in 2018. And unfortunately, over 20 fatalities because it occurred in the middle of the night, giant boulders and mud that came down in just 15 minutes of very heavy rainfall. So this is an example of some of that post-fire analysis that's done. This is an example of the Caldor fire and the Tamarack fire. And a little bit hard to see here, but here's Highway 89. Here's Echo Lake. Here's Highway 88. There's Luther Pass Road. And then this is Highway 50 coming down into the canyons west of Echo. And so this factors in not just burn severity, but also slope of the terrain, a lot of geology as well. And so those areas in red are the higher risk for those debris flows if we get that heavy rain. So of course, the steeper slopes in that area along Highway 50 west of Echo is a real big concern for the debris flow. It's more of a moderate concern for the areas south of South Lake Tahoe. There are, obviously debris flow is a concern, but it's not as high a risk as it is further west along Highway 50. Now for the Tamarack fire, there are some big concern areas around Markleyville for some debris flow flooding situations, especially with regard to steep slopes and things like that. So this is the kind of data that we use to help make flood warning decisions. Now, got a few more slides here and then I'll wrap it up. I love this one, especially when it comes to seasonal weather prediction. Predicting the future is hard. Just remember your March Madness bracket. And so I've got a couple of statements here that may seem kind of strange, maybe provocative, but it's kind of a philosophy change that we're undergoing in the Weather Service right now. So number one, all weather forecasts are wrong, but some are useful. And you're probably just now thinking to yourself, wow, he finally admitted what I've known for decades. They get paid to be wrong. I knew it. Well, honestly, if it depends what you're predicting. Like if I'm going to tell you, okay, Reno is going to get 2 inches of snow with the storm tonight, no storm tonight, but just say 2 inches of snow. It may depend on what side of town you are on, what side of the campus you're on, what side of the building you're on. You may see a totally different situation. You're gonna be like, oh wow, that forecast was terrible. But how can we make the forecast useful? And that's where we start using that probability, that scenario information, like I showed you earlier with those snowfall forecasts, to give folks more of a breadth of potential outcomes to be prepared for various contingencies and various scenarios to help them make better weather-based decisions. As Jeff did in my introduction, we're trying to help folks make better weather-based decisions. So making forecasts more useful by providing good statistics. And that's a big thing beyond day 3. We're realizing that the meteorology is always important, but it's really important to be a good statistician, especially beyond day 3 in a forecast, because that's where you're crunching those numbers. The physical reasoning behind things isn't as important as it is being able to analyze hundreds of different models in a statistical framework to come up with various scenarios for what's potentially coming to give people a heads up. So that's how we're changing the forecast, how we do the forecast. Gone are the days where we just sit there and compare, well, the GFS says this, the European model says that. Who's to know? Or worse yet, this is my favorite. My gut feeling tells me the European is right. Well, what? Based on what? So trust me, there are forecasters that do that. Not here. But that's something that we're trying to change the way of. And so now instead of doing that, we take all the models together and blend them together and produce scenarios, probabilities, threshold probabilities, more useful guidance for folks. This is an example from that storm in late January of this year. So the goal is, again, to help make more informed weather-based decisions. And we're trying to bridge the gap of the deterministic and the probabilistic, because historically our forecasts have been deterministic, where we just give you one number and go forth and prosper. But now we can give you that extra probability information as well. But there's still a lot of users that just want that one number, and then they plug it into their own model and then they go forth. They just want the most likely scenario. Hey, that's cool, that's fine, but we can give you other information as well. This is an example of that, showing you the most favored snowfall scenario, but also showing you some threshold probabilities as well. And we're doing this with river flood forecasts as well. This is the Truckee River at Vista during that October atmospheric river, showing you the most likely deterministic forecast here on the black line of river stage. But here are some possibilities based on different weather scenarios that were wetter. And we actually got really close to the monitor stage out of this. So this gave us a heads up that there was a chance that we could go a lot higher than that single deterministic forecast. So that was useful guidance to give our partners prepared for that low probability but feasible scenario. All right, so I'm going to wrap up with this, and this is really, the more I talk about this, the more I was like, oh, this is a really good thing to really start talking about, because a lot of times, if you ask an operational meteorologist about climate change, they get all squeamish and suddenly very quiet. It's not that they don't believe in it. Most of us see it every day. It's just not our area of expertise, and so we're just not comfortable talking about it. But I've been in this job long enough where, especially lately, I'm seeing, the climate's changing and our models are getting good enough. So our models are starting to show us these extreme scenarios ahead of time. And it's like, oh, how do I believe this? Is this possible? And then how do I communicate that and not send people into a panic. So I have two examples of that. One is that heat wave in the Pacific Northwest. So Portland, Oregon, I think it ended up actually at 117, which ties. It's the same all-time high temperature record as Las Vegas. Who had that on their bingo card going into this year? I did. I sure didn't. So, I mean, wow, just truly historic heat wave, smashing records by lots and lots of degrees. So our models, that national blend of models, actually showed that scenario 6 days in advance. Look at this. 6 days in advance, some of the high-end scenarios were showing 114, 116, 118. And I mean, their all-time record was 108. So, I mean, this is like way above that. And, you know, honestly, at this point, we're like, how is this possible? Is this even right? Is the model broken? Is there something wrong with the statistical processing? You know, we're just like meteorologists, we're just like dumbfounded at this. How is this even possible? And then, of course, fast forward and you're like, ooh, I guess it was right. So this is a light bulb moment for a lot of meteorologists, especially in the West, that were paying attention to this of, wow, not only our models are getting good enough, we know the climate's changing. So our models are starting to show us these extreme scenarios well in advance. So how do we communicate these scenarios without sending people into a panic or thinking that we're being alarmist? And so the strategy is showing them the most likely outcome, which even in this case at 109 would have been a record-setting event. But saying, hey guys, you know, there's actually even some models that show with a 10 to 20% chance that we could be even much hotter than that. And talking to those as extra information, you still show them that most likely scenario, that deterministic forecast, but then show them through probabilities of those potential extreme scenarios. So another case of that is closer to home, that big atmospheric river in October. This is the precipitation that was actually observed. So you see, you know, over a foot of rain on the west slopes, you know, half a foot of rain, measured rain in half a feet in the Truckee Tahoe Basin, 3 inches of rain at Reno. So here, the box and Worcester diagram of that national blend of models for the Reno airport was showing some of these scenarios. I mean, even worse ones. I mean, three inches in this 24-hour period, and actually, you know, close to 3 inches in the preceding 24-hour period. So there's 6 inches there at the 90th percentile. And again, it was like, man, can we believe these? Is this feasible? We know this is a big atmospheric river. How is this much moisture going to make it past the Sierra? You know, so again, these seem outrageous, but well, never mind. Yeah, a lot of this came to pass. Now, of course, it ended up being not this 90th percentile scenario, but it came really close to the 75th percentile, some of these really extreme outcomes. I mean, well, honestly, they had 8 inches of rain in Verdi, so that's not too far away. So there's your 90th percentile scenario there. So how do you communicate that? Again, you know, and then that affects the rivers. So the middle of the road scenario would not cause any problems, but that 90th percentile, that's going to cause significant flooding. So we had to kind of think on our feet and change how we do our messaging. Like, here's the most likely, but there is a decent chance that we could be significantly wetter. So again, you know, our models are getting good enough where we're starting to see these extreme scenarios that they may have a climate change component. That, again, is not my area of expertise, but we, as a meteorologist, we're seeing more and more of these, outlier scenarios happen. And so our models are starting to pick up on those well in advance in the new climate. So our job is changing because we're having to adapt to how to communicate those well in advance. So I'm going to end with this. A lot of you have known me for a long time. And when I first started in this job, I was trying to think of ways to communicate the forecast in an interesting, fun, humorous way. And of course, that ended up into the Freakout Chart, which we all know and love. Our regional headquarters barely tolerates it. But it started off with this: the wine and trash can scale for snow and wind. How much wine should I stock up? How far is my trash can going to go in the wind? And this lasted all of maybe like a week before our regional office put a kibosh on the wine scale. Thou shalt not do wine scales. But I always like to look back on it. And I will say, ahead of this next series of storms, you know, tomorrow afternoon, Saturday, Sunday morning, take some time to stock up, because where you are on Monday may be where you stay for a few days, especially if those mid and high range snow scenarios work out in the Tahoe Basin. So I'll leave it with that. I appreciate your attention. Lots of material. I hope you got a few nuggets out of this, and thanks again.
Thank you, Chris. That was great, especially the wine scale. I've got an online order ready to send.
Oh yeah.
So we have a number of questions. We'll try to get through as many as we can. So the first one, talking about GFS that you mentioned on one of your slides. Could you say something about what GFS is and how that compares to other models?
Yeah, I see the question here. So talking about the GFS, how does it get created? How is it different from other models? So there are various models all around the world that do simulations of the global atmosphere at basically like out to 14 to 16 days into the future. So the GFS is the American version of that model. It's roughly at a 13-kilometer resolution. The European Center, which is a cooperative of various European countries, has a global model as well. That one is run at 9-kilometer resolution, so a little bit higher definition than the US one is. There's the ICON that comes out of Germany. There's a Canadian model, obviously from Canada, and various countries run their own. And so we actually take all of these models and put it into that national blend of models that I was talking about to show you the statistical relationships there. So we look at all those models. I will say we actually have a few ICON believers in our office. It's actually a pretty decent model to look at in terms of a deterministic scenario for the region. So it's definitely one we take a look at as well.
So if you're actually seeing the chat, why don't I let you just moderate this yourself?
Yeah, no, thank you. Yeah. So a question here, I feel like I never really heard about atmospheric river events several years ago, and now they're somewhat common. Is this due to a trend of more extreme weather events? And have there been more AR events in recent years? Is it a new term, or did I just used to pay attention to weather less often than I do now? So it is sort of a new term. It is what Pineapple Express used to be. You know, these streams of moisture out of the tropics were they kind of reclassified them as atmospheric rivers, basically the same thing. These big streams of moisture that come into the West Coast from the tropics. Are they becoming more frequent? I don't necessarily have a good answer on that. Each year, there's wide variability between the numbers of ARs that hit California and Nevada. Some years like 2017 are extreme and we have like 30 of them or more. Other years, we just like 2015 during the middle of the drought, we have like 2 of them as an example. So they do fluctuate widely from year to year to year, but they are super important for the types of big storms that we get here. Got another question here. What is the estimated snow depth to be expected in the Truckee area? In addition, when should we expect the main snow period to take place? So I'm actually going to call up my fancy national blend of models here and look at the Truckee forecast here. I absolutely love being able to look at real data in real time here. So with the Sunday system, it's starting Sunday through Monday and then Monday here. So we're still going to start to see some light snow during the day on Sunday, but the snow amounts really ramp up Sunday night, Monday, and through Tuesday. Right now, I see the peak snowfall rates for Truckee are going to be on Tuesday with that storm coming in. But really, anytime Sunday afternoon, Sunday night, Monday, and through the day on Tuesday is where we're looking at the most impressive snow amounts for Truckee. And, you know, middle of the road for Truckee with that event, let's see, we're looking at about, 15 to 20 inches out of that one. And, a high end event of a couple feet. So yeah, it's looking pretty good for Truckee, maybe even 3 feet if all the stars align. So good question. Thanks for asking that one. So the next question here, I've been hearing lately about long-term predictions showing the Sierra will have successive years of no snow by 2040 and 2050. These are more climate related than meteorological, but can you speak to these projections? Are these worst case models or likely scenarios because we're getting drier, warmer, or both? So I can't really speak to this one a whole lot. And this is not my area of expertise. And I saw the story, I did read about it, but I'm not familiar with the original research going into it. I do know that the latest climate change models for the coming decades, what they're showing for the area is definitely warmer conditions on average, but the precipitation is more scattered. Some of the models show drier, but some of the models actually keep precipitation amounts near where we are now, or maybe even wetter, and more, especially for the Great Basin, but even the Sierra. So a potential scenario that ends up with little snowpack for the Sierra is we get storms, but they're just a lot warmer. And so we just see a lot less snow out of them. So that's where, if we start seeing precipitation types as more liquid than solid, that would end up as a scenario with little snowpack. But we end up on the precipitation accumulation, maybe even close to what we get right now on average. But we have to rethink, okay, where do we get our water supply from then? So that brings in a lot of policy issues there, of course, as well. How and when can we watch a recording of this lecture? I would like to recommend it to others. So I'll let Heather answer that one. Thank you, Megan, for the kind words, and Lauren. Let's see, Ben's got a comment. Thanks very much for this. As a skier and a taxpayer, someone who cares about NorCal, the Sierra Nevada, I really appreciate another one ahead of the spring skiing season would be great. Thanks again. Yeah, Ben, and that's the thing. We've honestly seen March is becoming the new winter month, if we will. I've seen more often than not, March seems to be a very busy month storm-wise for us. And historically, it's not been as important for the snowpack, but lately it seems like it is. I don't have any stats to back it up. It's more of a personal feeling that it just seems like March is busier than it used to be. It's like winter seems to want to wait to start, but then it doesn't want to let go once we get into the spring season. But again, that's just Chris talking. I don't have any stats at the ready to necessarily back that up. All right, John Scott, how the forecast for precipitation in the Tahoe area impact the water shortage in the Colorado Basin and Lake Mead? So those are totally different catchments, totally different hydrologic basins. So the precipitation forecast of the Tahoe area isn't too related to what that is for the Colorado Basin, although typically La Nina years, the further south you get, and this does kind of impinge on the Colorado River Basin, do favor drier than normal winters. So unfortunately, going into the shortage that's being declared for next year, this weak La Nina does tip the dice, load the dice for the Colorado Basin to being drier than normal, unfortunately. But again, I said load the dice. So we could still potentially end up with an active winter in that area, but if you keep rolling the dice, most of them would come up drier than normal for the Colorado Basin. So that's kind of the linkage that I see there. Jonathan Scott, will models still function well as global temperatures rise and modifications to address that? Really good question. The best answer I can say is they adapt to it in real time, because our models take into account real time ocean conditions and atmospheric conditions, and and then run the physics calculations to go along with that. So the presumption is the physics of the atmosphere in a changed climate wouldn't necessarily change, but the values of moisture in the atmosphere, the temperatures of the ocean, the temperatures of the land, that stuff will change, but that would be integrated in with the analysis of the model. And then it goes forth to run its calculations based off of that initial condition data. The atmosphere is going to be capable of holding more moisture in a warmed environment, which is one of the reasons why in the climate change models, they do suggest that the precipitation for like California, Nevada may end up being roughly the same, at least up here in the north, just because the atmosphere can potentially hold more moisture. Another thing I've seen is that we would see fewer storms, but when they do happen, they'll be bigger, again, because the warmer atmosphere can hold a little more moisture. So our models should be up to the task of handling that changed environment. And I've seen evidence with those two examples I gave you that they seem to be at least able to indicate those potential change scenarios. When you mentioned this from Jake, when you mentioned the October AR having very little rain shadow effect coming into Reno, what is the main contributor to that? Is there an elevation component of the storm? Excellent question. There's been a lot of research done on it, but fundamentally for efficient spillover, it's what we call spillover. So it's either rain shadow, where you typically have just strong winds and dry conditions in the east side, or spillover, where the winds are just gusty, but you have precipitation making it past the Sierra Crest. It needs a storm that has a giant sponge of moisture. So, and it's warm, and that moisture depth is really deep to many, many thousands of feet. And that makes it easier for that to come over the crest. So let's say you've got that giant sponge of moisture, it's really tall, and then It comes up to the Sierra. As it comes up and over the Sierra, it gets squeezed out. Air comes up the mountain, it starts condensating and precipitating. But there's so much left over when it comes to the east side that it can't help but have more precipitation fall on the east side. So it's the intensity of the storm, it's the amount of moisture available. It's also, there needs to usually be some mechanism to continue squeezing the moisture out on the east side. So usually a cold front in the area can do that. A jet stream, a piece of the jet stream is another feature that can do that, that can help keep the lift going to help squeeze more moisture out here on the east side. So that's what we saw with that storm in October, is the jet stream was oriented in a really favorable fashion for a prolonged period to keep that lift going on the east side and squeeze out more moisture. So good question. Let's see. Do you think the great ski race from Tahoe City to Truckee in March will be run this year? Ooh, boy, putting me on the spot here. Well, what did I say? I think if the storm for the next, let's say the storms that we've got on deck for the next week pan out, especially at the mid to high scenarios, I think the odds for that race to occur are pretty good at this rate, because you're going to build a phenomenal base of snow just out of a series of storms. Remember, it only takes a few storms to make or break our winter. We get a few, just even 3 good winter storms, and man, our winter is set in many respects. So that's kind of my answer to that one. Velma's got a question. Do you find that historical data is less useful because of our changing climate? Ooh, nice question. So I think that's a valid concern. I don't have a good answer to it, but it's something we talk about as forecasters all the time, is do our statistical correlations in the past mean as much for the future? And I think one of the best examples of that is El Nino and La Nina. Does the model of what El Nino and La Nina does to the jet stream track and the storm track, is that different now because the global climate and the ocean temperatures are changed? A lot of those relationships are due to the tropical Pacific Ocean water temperatures being either cooler or warmer than normal. So what happens when the ocean temperatures north of that are dramatically different? Does that change that relationship of where the jet stream goes? And an example to that is, remember Godzilla El Nino a few years ago? That ended up being exactly the opposite of what an El Nino should be. So it threw us for a loop there. So I think that there is concern that our historical relationships may or may not be valid for predicting what's coming in the future because of the changed climate. So good question. Scott's got a question. Is there any lake effect moisture related to the spillover that you are mentioning? Is Tahoe too small to change trees? Oh, wonderful question. Lake Tahoe is a really big lake effect producer. Happens a few times a year when we get really cold air that comes over the lake. But what we've seen a couple examples of it already this year, where Lake Tahoe has enhanced precipitation coming into Nevada. Pyramid Lake does the same thing. It will enhance precipitation coming into Sparks and Fernley and areas east of Reno through a lake effect process. And these can create what are called lake effect snow squalls, little really narrow bands of heavy precipitation, heavy snow mainly. So we do get lake effect off of Tahoe. Often it's in the fall or early winter when the lake is still relatively warm. So Tahoe is big enough for lake effect. Pyramid Lake, believe it or not, Walker Lake down by Hawthorne can produce lake effect. And last but not least, our friends at Mono Lake can produce lake effect as well. We've seen some pretty impressive situations for June Lake Mountain, and that's attributable to some lake enhancement coming off of Mono Lake. So good question. And we got one last question came in just under the wire from Ben. Is there an opportunity to get more out of what's coming storm-wise with cloud seeding? That one I can't answer. I'm just not involved in the cloud seeding experiments at all. That's more of a question for our friends over at the Desert Research Institute there. But I do know cloud seeding can enhance precipitation. To what extent, I just don't know. Rebecca's got a question here. Thanks for this presentation. I'm curious how the Washoe Zephyr winds play into weather and anticipated fire behavior. So basically, it's a wind that we see every afternoon in basically from Truckee to Reno and sometimes further east. It usually gusts 25, 30 miles an hour. And so when we do get that wind, it can increase fire behavior. It can cause fires to spread more rapidly. And so we're on, it's something we get every day. Now, when that Zephyr is stronger than normal, so if it goes into that 35, 40 mile an hour wind criteria, and usually that takes a little passing storm system, or if the temperature difference between the Sierra and the lower elevations of Nevada is even bigger than normal, you can get that stronger wind. That's when we issue red flag warnings. That's when the fire weather conditions become what's called critical, where the fire can spread really rapidly before first responders can get it under control. So the Zephyr wind is almost an everyday occurrence, but there's a few days each year where the Zephyrs, we call it a Zephyr Plus, gets enhanced a little bit, and can cause fire weather concerns there. So can you do a similar presentation after winter and predict the fire season? Well, I do that actually pretty often in the springtime. So if anybody's ever interested, feel free to set it for your group, send me an invite. I'd be happy to do it. Honestly, at this rate, I mean, if we end up with a decent winter, fire season in the mountains, hopefully will be less severe than what we saw the last couple of years. But on the flip side, for Nevada, when we have wetter winters, or we have really wet falls, actually, which we have, that can be mean a bigger fire season for the Great Basin. So I think we're caught up on questions there.
Yeah, we are. You did an incredible job addressing all those questions. Thank you, Chris. Thank you, everybody who attended and for posing those questions. And Chris, that was a wonderful presentation. I think you brought joy to many people's hearts. People are getting their skis and snowboards waxed. With that said, everybody have a safe weekend, survive the storm, have fun, and hopefully we will see you all at our January science seminar. Okay, thank you all. Have a great day.
Awesome. Thank you. Take care. Have a great holiday.